Hello student, videos we see the capacitors and capacity of capacitor means capacitance. So here capacitance, our next point is capacitance of a parallel plate capacitor without a dielectric. So we already learned about dielectric in 11th standard. So now here a parallel plate capacitor consists of two thin conducting plates, each of area A held parallel to each other. This is first line, this is the first plate of capacitor and this is the second plate of the capacitors. Okay, so this is the parallel to each other at a suitable distance d apart. The plates are separated by an insulating medium like paper, air, mica, glass, etc. So we know that the insulating. So one of the plates is insulated and the other is earth. So first one is insulated and second one is earthed as shown in figure. Okay. So when a charge plus Q, this is the plus Q, is given to the insulated plate, then a charge minus Q is induced on the inner face of the earth plates and positive Q is induced on its further face. But as this face is earth, the charge plus Q being free flow to earth. In the outer region, the electric fields due to the two charge plates cancel out. The net field is 0. Means in inner side plus first plate induced a positive charges. So here these electric field lines, this line shows the electric field lines. So this positive charges induces on the other plate is the negative charges in inner side, but in outer side of the two plates E is equal to 0. Means net electric field is equal to 0. So first find out in outer region. So we find out the electric field is equal to in outer region. So electric field due to the two charge plates cancel out. So net field is 0. So mathematically we prove that therefore E is equal to E1 plus E2. E1 means electric field for the first plate. E2 means electric field for the second plate. So net field is E. So E is equal to addition of first plate of electric field plus addition of second plate E2. So therefore E is equal to sigma upon 2 epsilon naught. We already find out the electric field on the plate in this lecture, last videos. So sigma upon 2 epsilon naught plus E2 is the minus charges. Here plus charges, so giving a sign, magnitude of sign is plus, but here magnitude of E2 is for negative charges minus Q upon 2 epsilon naught because your charge is minus. So here plus get here minus, we get sigma upon 2 epsilon naught minus sigma upon 2 epsilon naught, which cancel out to each other, then we get E is equal to 0. This is the outside of the plates. Now in inner region, inner region, electric field between the two charge plates is added up. So E is equal to sigma upon 2 epsilon naught plus sigma upon 2 epsilon naught is equal to sigma upon epsilon naught. because 2 here 2 sigma, so 2 to cancel out, we get here sigma upon epsilon naught. So therefore E is equal to sigma means nothing but the what? Surface charge density. So surface charge density sigma is equal to Q upon A, charge upon area. So Q upon A upon epsilon naught. So therefore E is equal to Q upon A epsilon naught, rearranging the equation. So we get here final equation for the capacitance of a parallel plate with capacitor without dielectric. Okay. So here V be the potential difference between the two plates. Then the electric field between plates is given by E is equal to V upon D. Here V means potential difference and D is the distance. So V is equal to ED. In this equation V is equal to ED. So V is equal to means potential difference is equal to Q upon A epsilon naught. This is the formula for E, and into D, and C means capacitance of the parallel plate, capacitor. So in that C is equal to Q upon V. So put up the value of V in this equation, we get Q upon QA epsilon naught D. So QD upon A epsilon naught. So Q here cancel out, then we get A epsilon naught upon D. This is the final equation for the potential difference, capacitance of the capacitor. We find out here electric field, and we will find out capacity of a capacitor, means capacitance of the capacitor without dielectric.